Good afternoon. These are the solutions to the practice test A that is for your tests coming up on chapters 5, 6, and 7. So this is practice test A. We're going to get started. The first part of it says to simplify. So what I want you to look at first is I want you to look on the outside of each one of these parentheses, and you want to see if there's something on the outside, on the outside of those parentheses, because that is where, if there was an exponent on the outside, then we would have to give that exponent to everything on the inside of each of those parentheses. We don't have anything there, but if we did, we would have to do that first. Okay? So now that we've focused on that, I want us to look at our numbers. So our first number is -2, and our next number is 4. So the first thing that I'm going to do is I'm going to multiply -2 times 4. And that gives us -8. And -8 is a value. Because it's negative, it does not go to the denominator, because -8 is just a coefficient. It's a number, a constant. We are going to multiply that times a variable, but because that -8 is negative, that does not mean we take it to the denominator. The next thing that we're going to look at is we're going to look at our a to the -5 and our a to the -2. We are multiplying those, and when we are multiplying, we add the exponents. Now, even though those are negative exponents, we can still add them together. So I end up with -8, a to the -7th power. Now, we're going to deal with this negative exponent. So look carefully at the difference between that -7, which is an exponent, which means we are dealing with a reciprocal, and that -8 right there. That -8 is a coefficient, so we don't move it at all. So the -8 stays in the numerator. A to the -7th goes to the denominator and becomes +7. Okay? Number 2. This is what I was talking about, to be sure you're on the lookout for on the outside of parentheses. So everything inside this parenthesis is raised to the -2 power. So that means that -2 belongs to everything inside that parenthesis, including my numbers. So I am going to do that first. So I have 4 raised to the -2 power. Then I have x to the 7th raised to the -2 power. And when that happens, we multiply the two exponents together. When you're raising a power to a power, you multiply. Then I have y to the -4th times -2. That -2 also belongs to everything in the denominator. So I have 5 to the -2, x to the -2, y to the 2 times -2, and z to the -2 times -2. Okay? Now I'm just going to kind of combine the exponents. I'm not going to start moving anything around yet. I'm just multiplying the exponents that need to be multiplied. So I have 4 to the -2. Okay? Then I have x to the -14, y to the +8. Okay? Let's do the same thing on the denominator. 5 to the -2, x to the -2, y to the -4th, and z to the +4th. Now what I'm going to do is I'm going to start moving those things around. So I've got 4 to the -4th. That becomes 4 squared in the denominator. I have x to the -14th. That becomes x to the +14 in the denominator. Now my y to the 8th stays in the numerator because it's already a positive exponent. Okay? Now I'm going to deal with a couple of things in the denominator. 5 to the -2, that's going to move to the numerator and become 5 squared. X to the -2, that's going to be x to the negative 2 is going to move to the numerator, and it's going to be x squared. Then I have y to the negative 4th. That's going to move to the numerator and be y to the 4th. Then my z to the 4th is going to stay in the denominator. So I'm going to rewrite that just because it got a little bit moved in with the rational on top. So I mean, I've got 5 squared, y to the 8th, x squared, y to the 4th, over 4 squared, x to the 14th, z to the 4th. Okay, now we're still not done because we've got some things that can simplify. So the first thing I'm going to do is I'm going to look at my numbers. 5 squared is 25, and 4 squared is 16. Okay, so I've just raised those powers. Now I'm going to go ahead and deal with my x's. So I want you to look, I've got x to the 2nd and I've got x to the 14th. They're both positive exponents, so I'm good there. But I've got x squared on the top and x to the 14th on the bottom. Now, I have more on the bottom than I do the top. So my x is going to stay in the bottom, but I'm going to go ahead and subtract. What's 14 minus 2? That gives me 12, and so then I have x to the 12th in the denominator. And so my x's are taken care of. I have y to the 8th and y to the 4th in the numerator. That's going to become y to the 12th in the numerator. And then I have z to the 4th in the denominator. So I'm going to take another glance, make sure there's nothing else that can be simplified. And there's not, so I am done with this particular problem. Okay, let's move on to number 3. Number 3. This one is the square root of 126. Now, if you're like me, I don't have 126 I don't really know what to multiply 126 by or what to divide by. So I'm going to do the prime factorization of 126, and then I'm going to move on from there. I know it's even. I know that, and the reason that I know it's even is because it ends in a 6, and anything that's even means that 2 goes into it. So I know that 2 times something is going to give me 126. And when I divide 126 by 2, I end up with 63. 63. Okay? 63 then breaks down to 9 times 7. 9 breaks down to 3 times 3. So my prime factorization of this is 2 times 3 times 3 times 7. That's my prime factorization. So I'm going to rewrite this as 2 times 3 times 3 times 7. And as you know, if I have 2 inside, then I am going to pull those out and I'm going to rewrite it as 1 on the outside. So think about that for just a second. 3 times 3 is 9. And then I'm taking the square root of 9 and I get 3. So that's how I end up with that. The 14 comes from me multiplying what's left over, the 2 and the 7 together, to get 14. So my answer there is 3 on the square root of 14. Okay. So what I have now is I have the square root of 27 over the square root of 6. And as we know, we cannot have a square root in the denominator. We can't do that. So what I'm going to do is I am going to multiply the top and the bottom by the square root of 6 over the square root of 6. And when I multiply by the square root of 6 over the square root of 6, I am multiplying by 1, and that's okay. Now in the bottom, square root of 6 over the square root of 6 just gives me 6. Okay? Now, I'm not going to multiply that out, the 27 and the 6th, because I'm going to have to break it down anyway. Now, I could multiply it out. I could say 27 times 6, and 6 times 7 is 42. 6 times 2 is 12 plus 4, and I get 162. I don't really want to do that, because if I do that, then I'm just going to have to break it down again. And so then I could break it down to 27 and 6, 9 and 3, and go from there. So I am going to skip this step just because I know that I'm going to have to break it down. So I've got my 6 already in there. My 27, I know that my 27 breaks down to 3 times 3 times 3. Okay? So that 3 times 3 times 3 is focusing on this 27. Okay? Then I'm going to focus on 2 times 3, because that 2 times 3 is my 6. So I have broken down that right there. So then I've got that over 6. I have one set of 3s, but then I have another set of 3s. So I'm actually taking 3 times 3. So one set of 3s gives me a 3, and the other set of 3s gives me another 3. So I have 3 times 3 on the square root of 2, and that is over 6. Okay? Now I'm going to rewrite 6 as 2 times 3, because 6 is the same thing as 2 times 3. And when I do that, I'm able to mark a 3 out. So my final answer to this is 3 on the square root of 2 over 2. Now remember, this 2 and this square root of 2 cannot cancel out, because they're not both inside or both outside. In order to cancel, they've got to both be inside or they've got to both be outside. So my final answer to this question right here is 3 on the square root of 2 over 2. Okay, 3 on the square root of 2 over 2. Now, I'm going to do this problem again because I want to show you another way to do it. Okay, so I'm going to erase now, and I'm going to show you another way to do this exact problem. And I think that this way is a little bit easier. So here we go. Okay, I am actually going to look at the square root of 27 over the square root of 6. I'm going to look at it as the square root of 27 over 6. It's exactly the same thing. Then I can simplify this. 3 goes into both of these. 3 goes into 27 9 times, and 3 goes into 6 2 times. So I can actually simplify the square root of 27 over the square root of 6 to the square root of 9 over the square root of 2. And when I do that, what is the square root of 9? We already know what the square root of 9 is, and that's 3. So I'm going to have 3 over the square root of 2. Now, we still have that situation where I've got a square root in the denominator, and I can't have that. So I've got to multiply by the square root of 2 over the square root of 2. When I do that, I end up with this 3 on the square root of 2 over 2, because the square root of 2 times 2, square root of 2, is 2. And remember, we cannot simplify these 2's because one is inside the square root and one isn't. So they have to stay like that. Now this method is a little bit easier when we simplify first. Now you can do it either way. But when we don't simplify first, it's a little bit more challenging because we get larger numbers. So I did want to be sure to show you this other method because I think it's a good method. Okay, let's start solving some equations. So here I've got n plus 6 equals the square root of n plus 6. So the first thing I'm going to ask myself is my square root isolated? And it is. In this situation, my square root is isolated. So I have the square root of n plus 6. It's already by itself. So we're good. Because of that, I can go ahead and square both sides. Okay? When I square n plus 6, I am going to have to FOIL that. So n plus 6 squared is n plus 6 times n plus 6. Now, the square root of n plus 6 squared, that's just going to be n plus 6. Okay, so when I square root that, I just get n plus 6. Now, I'm going to go ahead and FOIL. So I have n times n, that's n squared. N times 6 is 6n. 6 times n is 6n. And 6 times 6 is 36. And that equals n plus 6. So n squared plus 12n plus 36 equals n plus 6. Now, because it's a quadratic, and I know it's a quadratic because it's got that 2 right there, because of that, I've got to set it equal to 0. So I am going to subtract 1n from both sides, and I'm going to subtract 6 from both sides. Okay? So now we have n squared plus 11n plus 30 equals 0. Now, my next step is to factor, and this can be factored. So I'm looking for two numbers multiplied together that give me 30 and added together give me positive 11. Those two numbers are positive 6 and positive 5. 6 times 5 is 30. 6 plus 5 is 11. Okay, so now I set each one of these equal to 0. And my answers are n equals negative 6 and n equals 5. But we have been taught that we know we might end up with an extraneous solution. So we have got to check it. And the way that we check it is we take each solution and plug it back into the original problem. So I am going to have, so I'm checking negative 6. That's what I'm checking first. So I'm going to have negative 6 plus 6 equals the square root of negative 6 plus 6. Negative 6 plus 6 is 0. Negative 6 plus 6 is also 0, and that's the square root of 0. Some students get nervous about taking the square root of 0, but it's okay to take the square root of 0. The square root of 0 is 0. Okay, and if you had a calculator and you plugged it in and you tried to find the square root of 0, your calculator would not tell you error. It would just tell you 0. So having 0 inside the square root right here, 0 inside the square root is okay. You cannot have a 0 in the denominator of a fraction, but it is okay to have a square root inside the square root. I'm sorry, it is okay to have a 0 inside the square root. So, negative 6 works. Let's try negative 5. So I've got this, I'm checking negative 5. So I have negative 5 plus 6 equals the square root of negative 5 plus 6. Negative 5 plus 6 is 1. Negative 5 plus 6 is 1, and the square root of 1 is 1. So that also works. So n equals negative 6 works, and n equals negative 5 works. Sometimes you have to throw one of them out. Sometimes you have to throw both of them out. But it is always a good idea to check. Okay. Let's move on to number 6. Number 6 is 3x squared equals 1 plus 7x. 3x squared equals 1 plus 7x. So before we can do anything, we have to set this equal to 0. Okay? So I'm going to subtract 1 from both sides. And then I am going to subtract 7x from both sides. Okay? So on my right-hand side, I am left with 0. But on my left-hand side, I have 3x squared minus 7x minus 1. At this point, I can start asking myself, can this be factored? So if this is factored, I'm looking for a product of negative 3, and I am looking for a sum of negative 7. I get the product from multiplying my 3 and my negative 1 together. I get my sum by looking at my b. And there's nothing that I can multiply together to give me negative 3 and add together that gives me negative 7. So I'm going to have to use either the quadratic formula or completing the square. Now, When a is not 1, when I don't have a 1 in front of that x squared, then I'm going to go ahead and use the quadratic formula. That's just what I'm going to do. You could use completing the square if you wanted to. I'm not going to because it is not pretty. So here's the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac, and all of that is over 2a. Now, if you remember, the blue values are what I have to plug in numbers for in the quadratic equation. And I get that by making sure my quadratic is in standard form. So my a value here is 3. My b value is negative 7. My c value is negative 1. Okay? So I have negative b, and b is negative. So I'm going to have negative and negative, plus or minus the square root of b squared. And so that's negative 7 squared. Go ahead and put that parentheses around that negative 7. Students make mistakes there. If they're not careful, they don't square the negative. They just square the 7. You've got to square the negative and the 7 because b is negative 7, and we are squaring b. Okay? So I have negative 7 inside parentheses squared minus 4 times a, which is 3, times c, which is negative 1. And all of that is over 2 times a. Okay? So now we're going to simplify. Negative 7 is positive 7. Okay? Negative 7 squared is 49. Minus 4 times 3 is negative 12. Times negative 1 is positive 12. So I'm going to add 12. And all of that is over 6. 7 plus or minus the square root is 61. 49 plus 12 is 61, all over 6. Okay? And I can't simplify 61 at all. So I can't break it down to get a perfect square factor. So my answer is 7 plus or minus the square root of 61 over 6. Okay? Now, let's look at the next one. I have x squared minus 4x equals 53. Before I do anything, I'm going to pull that 53 over to see if I can factor it. So I have x squared minus 4x minus 53 equals 0. Okay? My product is negative 53, and I can't think of anything that goes into negative 53 right now. And my sum is going to be negative 4. So there aren't any numbers that I can multiply together to give me negative 53 and add together to give me negative 4. So I'm going to have to use the quadratic formula or completing the square. Now, my a value in front of x squared is 1. My b value is negative 4. So a is even, A is 1 and b is even. So that is a good opportunity for me to do completing the square. If you chose to do quadratic formula, you're fine. You're going to get the same answer. You are going to have to simplify some, but you are going to get the same answer. So it's okay to use completing the square. Just so I can help you guys see completing the square, I'm going to do this one with completing the square. So I have x squared minus 4x equals 53, because I moved that 53 to the other side. Now I'm going to take 1/2 of my b value. So 1/2 of negative 4 is negative 2. Then I am going to square that. Negative 2 squared is 4. So I add 4 to both sides. So I am left with x squared minus 4x plus 4 equals 57. Okay, now I'm going to factor x squared minus 4x plus 4. By design, we have created a perfect square trinomial. Okay, so I am looking for two numbers multiplied together that give me positive 4 and added together give me negative 4. And those two numbers are -2 and -2. So I have created a perfect square trinomial, and that is what we have to do when we're completing the square. That is by design. So I have x minus 2 squared equals 57. My next step is to take the square root of both sides. And remember, when you take the square root of that right-hand side, you've got to put that plus or minus in front of it. So then I'm left with x minus 2 equals plus or minus the square root of 57. 57 can't be simplified. Can't be simplified any further. And so I'm going to bring that 2 over. Now 3 does go into it. So let me make sure we can't simplify that. So 3 goes into 57. 3 goes one time. 1 times 3 is 3. So then I'm left with 27. 3 goes into 27 9 times. And so then we get 19. And 3 and 19 are, neither of those is a perfect square. So I didn't think we could factor anything out of 57, but I wanted to make sure. So now my last step is to add 2 to both sides. So my final answer here is 2 plus or minus the square root of 57. Now remember, that's 2 different answers. You don't have to write it as 2 different answers, but remember that's 2 plus the square root of 57, and that's 2 minus the square root of 57. Okay? That's what that is. Okay. Now we are solving a rational equation. And the way that we solve rational equations is we multiply everything by the LCD. Okay? Now, first thing I do is I look at my x plus 2 and I look at my x minus 2. And for 2, I just have 2 over 1. And I ask myself, do either of those need to be factored? And the answer is no, they don't. X plus 2 and x minus 2 do not need to be factored. So, they are going to be part of my LCD. And I've got to include both of them because they are each binomials, so they have to stay. That x plus 2 has to stay together, and that x minus 2 has to stay together. So we have to write them separately. So now I am going to multiply everything times my LCD, which is x plus 2 times x minus 2 over 1. So 3 over x plus 2, and I multiply that times my LCD, x plus 2 times x minus 2 over 1. Then I add that to 4 over x minus 2. And I'm multiplying by x plus 2 times x minus 2 over 1. And that is equal to 2 over 1 times x plus 2, x minus 2 over 1. Okay? Now I start canceling things out. So I have x plus 2 and x plus 2. So I'm left with 3 times x minus 2. Here I have x minus 2 and x minus 2. So I'm left with 4 times x plus 2. Okay, then over here on the right-hand side, I can't cancel anything out. So I've got 2 times x plus 2 times x minus 2. Now, what I would do is I would go ahead and FOIL this. Before I distribute my 2, I would go ahead and FOIL x plus 2 and x minus 2. Now, I'm hoping that you can look at that and you realize it's a difference of perfect square. I'm hoping that's what you see, and that my answer will be x squared minus 4. If you don't see that, that's okay. Go ahead and FOIL. X times x is x squared. X times negative 2 is minus 2x. 2 times x is 2x. 2 times negative 2 is negative 4. So my negative 2x and my positive 2x cancel. So on my right-hand side, I'm left with 2 times x squared minus 4. Now, I'm just going to bring everything down. Okay, now I have a whole bunch of distribution to do. So 3 times x is 3x. 3 times negative 2 is negative 6. I got ahead of myself there. 4 times x is 4x. 4 times 2 is 8. Then 2 times x squared is 2x squared. 2 times negative 4 is negative 8. Okay. On the left-hand side, 3x and 4x gives me 7x. Negative 6 and positive 8 gives me positive 2. Now, I've got a few things I need to move over. I am going to move 2 and the 7x here. And the reason that I'm going to do that is because that's going to keep my a value positive. We're going to have to use the quadratic formula anyway, but in general, we're just happier if that a value is positive. So I am subtracting 2 from both sides, and I am subtracting 7x from both sides. So the number that I'm going to be working with now, or the trinomial that I'm going to be working with, is 0 equals 2x squared minus 7x minus 10. Okay? Now, if you remember back from a couple of chapters ago, when we were factoring and we were solving word problems or equations, I would always look to see if there was something that I could divide all coefficients by. Like sometimes we got lucky and I could divide everything by 2, or I could divide everything by 3. Unfortunately, in this situation, we cannot. We cannot divide everything by 2 to make this nice and pretty. So we're going to use a quadratic formula. So I have negative b plus or minus the square root of b squared minus 4 ac all over 2 times a. Okay, so our a value is 2. My b value is negative 7. And my c value is negative 10. So let's do this. So I have negative b, which is negative 7, plus or minus the square root. And again, you want to put that negative 7 in parentheses so that you square it. So that you square the negative and the 7. Okay? So that's b squared minus 4 times a times c. And that is all over 2 times a. Okay, let's see. Negative 7 is positive 7. Plus or minus the square root. Negative 7 squared, that's positive 49. So be careful there. Then I've got negative 4 times 2, which is negative 8. Negative 8 times negative 10 is positive 80. So I have 49 plus positive 80 over 4. 7 plus or minus the square root of 129 over 4. And you always want to check. This is the last thing you're going to ask yourself. Can this be simplified? And what you're really looking for is a perfect square factor. But if you aren't sure if it has a perfect square factor, then you can do prime factorization to see if any primes show up twice. In this situation, 129 cannot be simplified any further, and so we are done with this problem. Okay, so let's move on. I think now we're moving into graphing, which is good. It's probably a little bit of a relief. So here we go. Okay. This particular problem is saying graph the equation using x and y intercepts. X and y intercepts. So I am going to do my x-intercept first. To find my x-intercept, I'm going to plug 0 in for y. So when you're looking for your x-intercept, plug 0 in for y. Okay, so I'm going to have 4 times 0 plus 20x equals negative 40. 4 times 0 cancels, so I'm left with 20x equals negative 40. I divide both sides by 20, and I get x equals negative 2. So if you write x equals negative 2, you're good, because I'm asking what the x-intercept is. So I'm going to put a point right here. There's my intercept. You can also write negative 2, 0 as the ordered pair. That is also correct. Okay, now I'm going to do the y-intercept. When I'm doing the y-intercept, I plug 0 in for x. That's how I do the y-intercept. So I'm going to have 4y plus 20 times 0 equals negative 40. 20 times 0 is 0, so I have 4y equals negative 40. I divide by 4, and I have y equals negative 10. Now, if you leave it as y equals negative 10, you're okay. Okay? You can also write it as 0, negative 10. Okay? What you cannot do, what is the wrong answer, is putting the two together and giving me a point of negative 10, negative 2, negative 10. That is incorrect. This is just wrong. These are two separate points, so you do not want to write them as one point. Here is negative 2, 0. Here is 0, negative 10. They are two separate points. Okay? And the last thing that I do is I draw a line. Well, it doesn't want me to draw a line. There we go. It's not a perfect line. It's definitely not a great line. But there we go. We have a line. Okay? So graph the equation using intercepts. Okay. Let's move on to the next one. Graph using the slope and y-intercept. And I give you a hint. You got to solve for y first. So this is what we're going to focus on first, solving for y. So I have negative 2x minus 5y equals 10. I'm trying to get the 5 and the negative 5 and the negative 2x away. I'm trying to get the y by itself. So the first thing I'm going to do is I'm going to add 2x to both sides. And I get negative 5y equals 2x plus 10. Now I'm going to divide both sides by negative 5. So I have y equals negative 2/5 x. Okay, negative 2/5 x. That's because I've got 2x divided by negative 5. Then I have 10 divided by negative 5. And that gives me negative 2. So I'm going to start with the negative 2. Negative 2 is my y-intercept, so that is where I start. Okay, my slope is negative 2 over 5. So that means I'm going to go down 2 spots, and I'm going to go to the right 5. Okay, and so here is my line. Right here. I'm not a great line drawer, sorry. Now, one of the things that happens, and you want to be super careful about this, because we have our negative slope, what happens is some students will go, okay, well, I'm going to go down 2, and then I'm going to go to the left 5. And the reason that students do that is because they're like, oh, I got to make sure I account for my negative. So what they've done is they've gone down 2, which is negative 2. Then they have gone to the left 5, which is negative 5. And they have turned their line into a line with a positive slope. And that is wrong. This right here is wrong. Okay, so you don't want to do that. Don't accidentally turn your negative slope into a positive slope. Okay? Don't accidentally do that. Okay, we're getting close to being done, I think. Getting close to being done. Okay, here's the next one. We are graphing horizontal and vertical lines. So this one I've got y equals negative 2. So if I were to do a table of values, and I'm not asking you to do a table of values, I'm just saying if I were, what this would mean is that every single one of my y values is negative 2. My x values can be anything, okay? But all of my y values have to be negative 2. So when I graph that, I end up with a graph that looks like this, okay? And it is a horizontal line where y equals negative 2, okay? So y equals negative 2 means all of my values for y are negative 2. My x can be anything, and we are looking at a horizontal line. Horizontal line. Okay, that's a horizontal line. And just for a little bonus information, the slope of a horizontal line is 0. Just to kind of keep that in the back of your mind. Now I want to graph x equals negative 2. So if I were doing a table of values, that would mean every single one of my x values is negative 2. Doesn't matter what my y values are, but my x values are all negative 2. So if I were to graph that, I would look something like this. Okay, to where every one of my x values is negative 2. So here I have a vertical line. So when I have x equals something, I have a vertical line. Okay, and just added bonus, my slope of a vertical line is undefined. It is not 0. The slope of a vertical line is undefined. Speaking of slope, let's find a couple of slopes. Okay. The formula for slope is change in y over change in x. Okay, I'm subtracting my y's and then I'm subtracting my x's. So another one that you might see is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Okay, so I'm going to start with this point on the right. So I'm going to have negative 10 minus 12 over negative 15 minus 7. Negative 10 minus 12 is negative 22. Negative 15 minus 7 is also negative 22. So when I simplify that, I get 1. So my slope for this particular problem is positive 1. Okay, let's do another slope. And we're going to do change in y over change in x. The other way is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And that just means whichever point we start with for y, we've got to start with that same point for x. So I am starting with 5, negative 4 for x and for y. So I have negative 4 minus negative 4 over 5 minus 3. So in this situation, I'm going to end up with 0 in the numerator, and I'm going to have 2 in the denominator. It doesn't matter what I end up with in the denominator because I have 0 in the numerator. 0 divided by 2 simplifies to 0. So if I have 0 in the numerator, that means my slope is 0. And that's completely okay. Having a slope of 0 or having a 0 in the numerator is okay. The alternative to that is when I get something like 2 over 0. When I get a 0 in the denominator, that's when my slope is undefined. That is not what's happening here, but it may happen another time. Okay, so when you have a 0 in the denominator, your slope is undefined. When you have a 0 in the numerator, that is when your slope is 0. Okay?